Good afternoon, everybody. We have got multiple tornado warnings in effect right now over southeastern Wisconsin. These are just to the west of the Milwaukee area, including Waukesha, down toward Troy, Elkhorn, Como was included, and we've got a skinny squall line, and you can see all these little inflow notches. Those are all QLCS tornadoes. Look at this one just to the southeast of LaGrange right now. You can see all those little loops. They're a lot more visible on reflectivity, on velocity. And a lot of times you get these skinny squall lines this time of year during the fall. These are quite common, a very high wind shear environment. Skinny squall lines capable of causing immense damage. And you can see all these little kinks within the line. These are all potentially QLCS tornadoes, even likely QLCS tornadoes. Anywhere where you see those kinks and you see a little bit of an RFD bulge, that's where you can get a tornado vortices. And you can certainly pick these out a lot more using the correlation coefficient product on this. I was just going to do a live update on those yellow boxes down in northeastern Arkansas to begin this severe weather event. But now we have got QLCS tornadoes happening right now. And there is one of them just southeast of LaGrange, Wisconsin. There's LaGrange. Here's Troy, Wisconsin. Here's Elkhorn as well. Definitely looking at an ongoing tornado. That's a debris signature, lofting debris into the air just southeast of LaGrange. And in fact, you have to match some of these up with velocity, but that is certainly a tornado right there. Look at that thing. There you can see it. We'll loop this a bit, try to see exactly where that tornado is happening. But there you can see where the QLCS tornado is located, right about here. That's LaGrange off to the northwest. This has a debris signature. That's velocity. We head on over to high-res correlation coefficient, and there you can see that tornado that is in progress just southeast of LaGrange. Not very far from LaGrange right now either. So that's probably 6-7 miles southeast of LaGrange. And look at that. The next radar scan, suddenly that debris signature now is not as prominent. So a lot of times these QLCS tornadoes will fire up, ramp up, produce a tornado, cause some damage, and then suddenly the next radar scan, those will be completely gone. But that's why you have to heed these warnings that are in place. Multiple tornado warnings. These are confirmed. Definitely the dual pole products of radar, very important to be able to track exactly where those are happening. Looks like some debris as well with this circulation just southeast of North Prairie, south of Genesee Depot. Definitely could be a tornado as well. You can see that little RFD bulge located. That looks like a tornado as well, just to the south of North Prairie. Definitely debris signature that's happening with that. And look at that bulge out. Here is the effective RFD bulge. Very strong westerly winds with this portion of the line as that bulges out. And then you have a little bit of inflow here wrapping around the north side. In general, this whole entire squall line forces a further right storm motion as well. So you're actually squeezing out even more wind shear than otherwise would be available for just a supercell storm. That is moving with the average of the flow that it is experiencing. Look at this one just near Elkhorn. If you're in Elkhorn, Wisconsin, take shelter immediately. You've got a dangerous QLCS tornado that's heading your way. A lot of times these will spin up just a little bit behind the gust front too. The RFD gust front will bulge out and you get what's called an occlusion within the line, and then that occlusion will become a tornado just a little bit behind the line. We're using Milwaukee radar. Let's go back over to the correlation coefficient. Looks like there is a possible tornado that's coming into Elkhorn right now. These are small tornadoes. They'll spin up really quickly, relatively quick time scales. These will touch down, produce a tornado, lift, dissipate, and then the next circulation will happen. So you want to look for those inflow notches. I'm going to reduce this to about 6 frames so that we can actually see that debris happen. But it looks like right there's a QLCS tornado that's probably coming into Elkhorn. It's hard to tell if that's a radar artifact with these fine scale tornadoes, but I do think that is a tornado moving west-northwest off to the east-southeast, heading toward Elkhorn, Wisconsin. You definitely don't want to get focused on just one circulation either, but that is a very well-defined QLCS circulation. The other one is right here just to the southwest of Troy by 5 miles or so. That one's wrapping up quite dramatically. You can see this little bit of a bulge. Those are enhanced westerly winds. And then just on the north side of that bulge, you get the spin up of cyclonic vorticity. And that's exactly what's happening there as well. We've got multiple tornado warnings in effect. 2 tornado warnings now for this portion of the line that's moving into southeastern Wisconsin. Pull up a couple more models here as well. I do want to show you exactly what's happening with the environment. I was about to do a live stream for subscribers only, and then all these multiple tornado warnings popped up, and it was obvious that I needed to go live immediately to get these tornado warnings out. Now there's 2 tornado warnings in effect over southeastern Wisconsin. These are QLCS tornadoes. It's a skinny squall line, but doesn't mean that it's less dangerous. These skinny squall lines and QLCS tornadoes are capable of causing major problems out here. There was a QLCS tornado that actually caused EF3 damage in El Reno a couple of years ago. So it's very possible. Definitely these can be extremely damaging. It definitely is a QLCS tornado. These but there is a fine line as well between a QLCS tornado and just a supercell tornado. Basically, they share the same gust front as well. So, making some changes here. I want to show you some of the environments as well. I did just get back from chasing the Hurricane Ian. My car is still down there, unfortunately, but that's okay. Can always use rentals as well. And right now I'm just breaking these down, just sitting on my rear end, which is also fine. It's right along the interstate right now from Elkhorn to Potter Lake. That's the danger zone. And it looks like this could be a QLCS tornado that has spun up just behind that gust front. So a lot of times what will happen when these QLCS tornadoes develop is you'll get a little bit of a bulge within the line. You can see that bulge with the skinny squall line, and this serves as an effective RFD. Basically similar to a supercell storm or your hook echo would be like that. You have an RFD bulge as well. The physics are relatively similar, except this line forces a further right storm motion, can actually squeeze out the storm relative shear more effectively than just an individual supercell storm that's embedded within the mean flow. But that is a supercell or a QLCS tornado right there approaching the interstate just south of Troy. Let's take a look at the correlation coefficient. And it looks like there's a hint of some debris getting lofted here. I'm not seeing a very well-defined debris signature with that right now, but it is kind of a broad area of debris. So I do believe that that's a tornado. It was a lot more well-defined a little bit earlier, but moving quite rapidly. There's a good chance that this is just debris that's suspended in the air, and the tornado may have weakened a bit, but these QLCS tornadoes will spin up very quickly, and a lot of times they'll spin up just behind the line, and I think that's what's happening here, where you have that velocity opposite in sign. You know, a bit of a bounded weak echo region there potentially. You can see all the way down to the ground. Probably an error in the radar, but you do have a bulge. And this did produce a tornado a little bit earlier. Still has debris that's lofted, has storm relative inflow along the north side of that bulge. Multiple tornado warnings remain in effect. 2 tornado warnings. Waukesha, you've got a tornado warning. I'm not seeing very much in the way of strong rotational signatures right now up in the Waukesha area. Just to the south is really where you start to get those stronger velocities, and you get a little bit more spin as well that's embedded in the line. Look at how wavy this gust front is. Very wavy gust front. A lot of kinks in the line. Even down south of that tornado warning, down to the west of Williams Bay, I could easily see that intensifying into a tornado warned storm as well. 2 tornado warnings. Yellow box off to the north, all the way up through Cedar Grove, Howards Grove, Sheboygan area. You've got damaging straight line winds are going to be the main threat up there with that portion of the yellow box. And you can almost see how these are embedded supercell storms, even though they do share the same gust front. When you look closely, look at this little embedded supercell structure just to the west of Cedarburg. You've got another embedded supercell near Germantown. You've got another supercell down here near Milwaukee, and another supercell just to the south of Waukesha. So even though the velocities aren't really showing these as having tornadoes on the ground, now a next scan, a couple of scans from now, they could definitely produce tornadoes very rapidly, and you could definitely see the supercell structure just to the south of the Landon area. Looks like the gust front has moved out just a little bit in front of that supercell structure, but this is where I'd want to watch for a kink to be pulled in with that gust front and for a tornado to develop. You can see that hook-like appendage on the southwest side. So definitely do have an embedded supercell structure right there. and you're not seeing as much in the way of velocity. Maybe up a little bit closer to Menominee Falls, down to the west of Brookfield, you've got some broad rotation. I'm not seeing a tornado right now, but it only takes one scan. You can go from that to one scan later, and you can have a tornado in progress. You definitely do have a pretty good bulge here coming into the Vernon area. Vernon, Wisconsin, out. Get in your safe place. Definitely share this stream. Hit the subscribe button if you like in-depth radar breakdowns. A lot of times I do this for subscribers and members only, just because the in-depth stuff doesn't seem to appeal to a very large audience, and I'm not as capable of making it as fluffy as I could, which would appeal to a wider audience. Definitely do dig in a little bit deeper into the radar here. Dual pole radar. Doesn't take an expert to break down radar, especially with these dual pole products. They make it almost easy to find these tornadoes, and it looks like we've got a tornado to the north of Spring Prairie right there in Wisconsin. Let's match that up with the velocity, and that's exactly where you'd expect to find a tornado as well, within that RFD bulge. Sometimes these tornado cyclones are even too small to be resolved by the individual pixels on radar here, and you kind of have to look for these little bulges and look for kinks within the gust front. Where you get those kinks, that's where you get storm relative inflow, and then it'll wrap up and occlude, and you'll get a tornado vortex that a lot of times will mature just behind that gust front. 2 tornado warnings happening in southeastern Wisconsin. We had multiple tornado warnings. Now they're just warning the whole entire line, because there are so many circulations to keep track of. You don't want to have like 35 tornado warnings. But you've got a circulation here just to the northwest of Butler. And zoom out a bit so we can see the whole thing. And also, this is well north of the slight risk. You can see that this is actually in a sub-marginal risk, but the Storm Prediction Center has a marginal risk up into central Ohio. This is along the northern edge of the front. The southern edge of the front, which is moving through eastern Arkansas right now, has had a couple of severe thunderstorm warnings. Tornado probabilities, basically relatively low, 2% all the way up. Doesn't mean that you're not going to get some mesoscale accidents, but the mesoscale accidents today are happening over southeastern Whiskey. So that was a circulation off to the north. You got another circulation out near Vernon. Another circulation just to the east of Troy. Another circulation north of Spring Prairie. Another circulation just to the north of Como, Wisconsin. And that's what makes these QLCS type tornado events so dangerous. They spin up really quickly. A lot of times shorter time scales. And let's zoom out a bit. Oh. Zoom out so that we could show this skinny squall line in action, and I'm going to loop it. And look at these supercell structures. This one down near Harvard probably needs a tornado warning as well. It definitely shows you the fine line that there is between a supercellular mode and a QLCS mode. So this one's just south of that tornado warning. Look at that supercell structure there. You can even see a little hook-like appendage, RFD structure. That's the supercell storm. That's that supercell shape that you can see. This does share the same gust front, which makes it a quasi-linear convective system, or a QLCS. Quasi-linear convective system. But a mesocyclone will be located there just to the south of Harvard. This is the Illinois-Wisconsin border. And it looks like another supercell structure up near Walworth, just to the south of Williams Bay. And then you got these supercell structures too. Look at that little hook-like appendage just on the south edge of Spring Prairie. Another supercell right there. RFD bulge in between. So all of these supercell structures are feeding off the very strong low-level wind shear that's in place. There's also sufficient bulk shear in place to get these rotating updrafts. I believe that the tornado is basically like a pipe, a tilted pipe of mostly pure updraft above the tornado. That's the mesocyclone, and then you have a sheath of a cyclonically rotating mass around it. That's what we always see when we're time-lapsing, when we're looking at storm structure that's obviously rotating. When you see those mothership supercells, I think you're just seeing the sheath that is to the outside of that actual pipe in the middle. But you can often see those bounded weak echo regions with supercell storms too. And I believe that when those radars are at a standoff range, that's really what you're seeing. is actually that pipe in the middle, almost like a smokestack in the middle of the storm. Supercell storms are not that dissimilar from a small-scale hurricane, just more tilted. They experience the wind shear, the baroclinicity of the mid-latitudes. So I believe that's similar to the eye of a hurricane, where you just have this pipe, a smokestack, all the way up with basically a donut-like sheath rotating cyclonically around it, except in a barotropic environment, so it's more vertically oriented. A supercell storm feels the wind shear up here in the mid-latitudes, feels the baroclinicity, and you basically get a smaller scale system, but tilted. So you still have that smokestack in the middle of it, tilted more due to the wind shear, and that's why. But you do have similarities even with these baroclinic systems that are of smaller scale and the larger scale, larger mesoscale systems. We got a new tornado warning now just to the south of Grafton. And Milwaukee, you're now under a tornado warning. If you know anybody in this area, please be sure to share this stream, breaking these down live. But there you can see Milwaukee right in the center of the screen. And we got tornado warnings going up all over the place now, folks. Kenosha, Southeastern Wisconsin is included. Milwaukee's included. We got a new tornado warning down near McQuan, Thiensville as well. And you can see those embedded supercell structures. Look at that. That's an embedded supercell structure. They do share the same gust front, which kind of forces a more due right storm motion as well. So you can actually take more advantage of the wind shear. Increases that storm relative inflow a bit. The intake of the streamwise vorticity. There's your rotation just to the south of McQuan in Wisconsin. You go a little bit further down, you've got another circulation near Butler, just to the west of Brown Deer as well. And this is warned in Milwaukee with sufficient lead time because this gust front is well off to your west, but it is moving very rapidly off to the east. We've got a skinny squall line here. These skinny squall lines happen a lot during the fall season. A lot of times they happen over the northeastern U.S. They happen when you have relatively low instability, relatively high wind shear that happens. And this is the most dangerous storm down near Lake Geneva, Spring Prairie areas. You can definitely see a lot of inflow there. Inflow notches all over the place. This is a dangerous storm right along the Illinois-Wisconsin border, north of Alden, southeast of Walworth. That's a pretty dangerous storm as well. Look at that circulation. You can see these kinks within the line, and look at how this gust front is very wavy. And then wherever there's a kink in that gust front, there's likely going to be a supercell structure that's embedded within that line, capable of accelerating the inflow a bit. Some storm scale processes that'll happen with these QLCS type tornadoes. Breaking it down live here, everybody. Big Bend, Wisconsin. You want to get in your safe place. Good, I thought my internet just went down there for a sec. Spectrum is just killing me. Zooming back out, we have tornado warnings. South of Grafton that include Milwaukee, include Kenosha. And I think that the most dangerous portion of this line might even be from this kink and off to the south. You want to watch for these mesoscale kinks in the line. See how this gust front goes northeast to southwest. And then right at near the Wisconsin-Illinois border, you've got a more due north-south orientation to that gust front. You definitely want to watch those kinks. A lot of times those are the northern nose of instability axes. A lot of times you get the most favorable co-location of wind shear and thermodynamics near those kinks in the line. But you also have the potential for tornadoes even to the north of that kink, where it's more southwest to northeast. Even though you've got a more consolidated gust front, it does seem like those velocities behind the gust front are stronger out of the northwest. So you get a little embedded supercell structure within that line. It pulls an inflow, develops a kink within the gust front, and then it can quickly spin up a tornado just behind that leading gust front. Look at that thing advance. Southeastern Wisconsin and rapid advancement. So it's encouraging rapid intake of streamwise vorticity too. Streamwise vorticity, horizontal spin that's oriented parallel to the storm motion. If a storm motion is moving parallel to a horizontally rotating tube, it can more effectively flip that horizontal vorticity into the vertical, and it can definitely more effectively produce tornadoes as well. And that's exactly what we're seeing here. Test 1, 2. Make sure my audio is even working. Look at that squall line advancing rapidly. And this forces a more rapid storm motion further right than it would be. If you just had a supercell embedded within the open warm sector, it would experience the low-level winds all the way up to the mid-levels and upper levels, and it would experience a storm motion related to basically an average of that vertical profile that the storm in which the storm is embedded. Would probably favor a more northeasterly storm motion if you just had an isolated supercell embedded within the open warm sector. But when you have a rapidly advancing cold pool like this, it's forcing a storm motion that's more west-northwest to east-southeast. That enhances the storm relative helicity in a storm relative sense, and also forcing this more rapid storm motion enhances the storm relative inflow of the low-level wind shear, and that's why these QLCS tornadoes are even more effective at taking advantage of the low-level wind shear available to them. Right near that kink where we were watching, right near the Illinois-Wisconsin border, you can see some more vigorous convection down in this area. Not surprising, and could definitely get some greater tornado potential as well near that Illinois-Wisconsin border south of Lake Geneva. Lake Geneva is included in the tornado warning too. Let's look at some of our dual pole products here. Let's look at the correlation coefficient and see if we're getting any tornadoes spinning up. There is a severe thunderstorm warning that's been issued down on the Illinois side, just south of the border. Maybe we're getting some fall colors getting lofted by some damaging straight line winds there to the east of Alden, just west of Hebron as well. This is the correlation coefficient product here. So what we're looking for is debris that's getting lofted. And you can scroll up and down this line and you can see there is debris getting lofted throughout this line. These are all individual tornadoes that are happening. So you got a tornado right here just to the south of Wind Lake, another one out near Waterford, another one just to the west of Rochester, this one just to the northwest of Burlington, another one south of Lake Geneva. So you can circle all those, and then now let's match it up with velocity. And boom, you can see that all those are associated with little kinks in the line. I am kind of surprised that this one just to the east of Lake Geneva isn't producing a tornado now, but I think that this one is just about ready to produce a tornado. You've got a couple of kinks as well just to the west of Burlington, Wisconsin. Larger scale bulge here. Possibly the northern half of that bulge would be more effective at generating tornadoes across that portion of the bulge. And boy, you can almost see this inflow pipe streaming into this developing kink or mesocyclone just to the east of Lake Geneva. You can also see this big inflow, and debris is getting picked up by this portion of the line. Whether that is actually a small scale tornado or is it just an accelerated westerly flow that's associated with that RFD bulge, I don't know right now, but you still want to treat it as a tornado, that's for sure. That could be a tornado coming into Hebron right now. It has a severe thunderstorm warning. There's a very fine line between these straight line winds that are lofting fall colors and these tornadoes. So either way, it's still capable of causing damage that a tornado might be capable of. Coming into Hebron, just south of the Illinois-Wisconsin border. It's got a severe thunderstorm warning. Possible that these are just destructive straight line winds that's associated with the RFD bulge. But there's also a chance that that's a tornado that's in progress. That is a little bit too small for the radar to resolve. It's definitely associated with an RFD bulge. This is a rear flank downdraft bulge, we'll call it. Basically a bulge in the gust front. Stronger westerlies are located behind this line. But it's also possible that you can get a quick damaging tornado that can develop, especially anywhere along the north side of that bulge. Ooh, it looks like that thing just lifted up further north. Look at that. Looks like it was about to produce a tornado, and then that dangerous portion of the storm is kind of lifted off to the north, closer to the Wisconsin-Illinois border. Let's take a look and see if there's any debris getting lofted right now. So it does look like that's probably damaging straight line winds, maybe some fall colors getting lofted between Alden and Hebron area. And it looks like that circulation's a little bit closer to the Wisconsin-Illinois border up here. So I'm waiting to see a more definitive tornado debris signature. But yeah, it looks like this is probably more straight line winds, lofting fall colors and whatnot. Ooh. Looks like that could be a tornado southeast of Wind Lake. That's probably also damaging straight line winds, picking up fall colors. You can see this big bulge here that just came through the Wind Lake area. There are some kinks in the line though. Anywhere you get those kinks in the line, it's very possible that you can spin up a quick tornado. But mostly these are very strong westerly winds that are likely picking up fall colors. Tornado warning though that is still in effect. Look at how fast this is evolving too. This line is moving very quickly. This one is approaching Milwaukee. So Milwaukee, get in your safe place. Definitely get in your safe place. There's the circulation. It's to the west of town, just west of Milwaukee, West Dallas area. Let's take a look at velocity and see if we can see where that tornado is located. This area is the area of rotation, heading right up into West Dallas. I don't know how you say that. But definitely could be a tornado located right there, west of Milwaukee. You definitely want to be in your safe place. Milwaukee, tornado warning includes downtown. Boom, we got debris signatures, it appears, with that circulation. West-southwest of Milwaukee, south of West Dallas. There's West Milwaukee as well. That's your likely tornado. Possibly down near Greenfield as well is getting some damage. Let's now relate that to velocity. Yeah, those are tornadoes. Greenfield, just outside of West Milwaukee, coming into Milwaukee. Circulations that have debris, that are lifting debris. You can see some embedded supercell storms, even though they're sharing that same gust front. See this little hook. You could also see the hook that's coming into Greenfield. Tornado happening right there as well. So Milwaukee, tornado warning, get in your safe place. Whitefish Bay up toward Bayside, Fox Point, all the way down to Oak Creek. We are right now tracking tornadoes in progress. West Alice down toward Greenfield. This is just outside of the western suburbs of Milwaukee. We have 2 tornadoes that are in progress right now. Look at that. Boom, debris signatures. Greenfield, just outside of West Milwaukee. These are actually 2 separate tornadoes happening. Here's downtown Milwaukee in the northeastern part of your screen. Big problems. There's Milwaukee. Tornado warning in effect. We are tracking it here at Team Dominator headquarters. Let's loop this and see just how recent. And boom, that tornado just formed just outside of West Milwaukee. Notice how these are moving more in a west to east direction. And they're quite persistent too. This tornado went from the New Berlin area all the way to Greenfield and is causing damage. Likely causing trees to come down, fall colors to get lofted, minor structural damage as well. I'd say we got a tornado outbreak in progress now. Tornado outbreak is happening. This is a live radar breakdown of this tornado warning. Thanks for tuning in, everybody. Hit that notification button. Please subscribe. If you know anybody that's in this area, please share as well. I'm just doing this live breakdown. My car is still down in Pine Island, so I'm just sitting on my ass these days breaking down radar. I'm going to call it a tornado outbreak, folks. Tornado outbreak in southeastern Wisconsin. This is a skinny squall line. A lot of times these happen this year, but you can also see embedded supercell storms within this line as well. Look at that. It's coming into Milwaukee right now. You got a tornado warning that's in effect. Get in your safe place. The tornado warning goes all the way down to the Illinois border. Skinny squall line with confirmed tornadoes is approaching. We've actually got confirmed tornadic circulations right now near Milwaukee. Can be hard to discriminate between damaging straight line winds and these tornadoes, and you really don't even want to split hairs like that, because there's a fine line between a tornado vortex and the straight line winds being enhanced by a mesocyclone causing winds that are capable of causing the same damage. So you definitely don't want to split hairs, but it looks like the south side of Milwaukee is likely has a fast moving QLCS tornado, lofting fall colors, causing some minor structural damage, likely downing trees as well. We are tracking it here live at Team Dominator headquarters. There you can see the reflectivity. Look at that. You can even see a hint at an RFD bulge within that zone. It's very possible that that debris that's getting lofted is due to straight line winds accelerated by the low-level jet, but we do see these mesocyclones that are apparent on radar as it's heading off to the southeast. It's likely that this is a circulation right here. This is a circulation right there. Those two circulations do have a correlation drop associated with them. It's very likely that that circulation is just enhancing the westerly winds on the south side of those, which would be capable of a little bit more damage, trees being down, structural damage, fall colors being lofted, or those could also be tornadoes, tornado vortices. It does look like that portion of the storm is a bit more significant than the rest too. Those circulations are definitely enhancing the westerly flow over the southwest side of Milwaukee. But that portion of the line is definitely most dangerous right now. That's why we're zoomed in on it. It's also a very populated area here in Milwaukee. And you still have that large tornado warning polygon that covers basically the whole entire southeastern portion of Wisconsin. Looks like you have an embedded supercell down here near Boners Lake, down here near Pell Lake as well. Just northeast of Boners Lake, you can see it looks like there's possibly an embedded supercell storm right there. And you can definitely see an associated RFD bulge. This is the bulge in the RFD. Accelerated westerly winds happening right there. Boom. And you actually pull in some inflow on the north side of that. So this is definitely the zone that you want to watch for the development of tornadoes with these QLCS lines. You want to look for those bulges, the RFD bulges. Again, there's Boners Lake just behind the gust front, just behind this RFD bulge. But this zone right here is a zone of storm relative inflow, pulling in just on the north side of that squall line. This is the shared gust front. It's a wavy gust front as well. Classic signature, usually just to the northern half of those bulges. That's where you get the greater likelihood of cyclonic vorticity generation to happen. A little bit further down toward Powers Lake. This is an area that also could be associated with the development of tornadoes. Northeast of Powers Lake, southwest of Wheatland. And that's where the tornado warning stops, right at Genoa City. We thought maybe we saw some damage with some straight line winds coming into the Hebron area just on the Illinois side. But we do think that that was more straight line winds. Very fast moving squall line happening here. Let's go back to Milwaukee and see what we got for debris signatures. It does look like this area is going to be capable of generating tornadoes, and it has been. But it does look like the velocity signatures are definitely subsiding. Probably just have some fall colors that still need to fall out of the sky there over the southern portion of Milwaukee. So this doesn't have the look of a tornado in progress. Probably some brief tornadoes wafted these leaves and branches, and they're still suspended above the ground, still being picked up by radar. I still wouldn't be surprised to see quite a bit of damage out there. Looks like possibly a brief tornado just to the north of Yorkville, Wisconsin. That would be up there. Got a couple of pixels. See how close that is to the velocity signature. And yes, probably are lofting some fall colors with that little nipple right there. A little bit of a bulge in the gust front. You can get a little storm relative inflow getting pulled on the north side of that, and can very easily get a tornado vortex. That's just to the north of Yorkville. This small vortex is probably going to pass just to the north of town. If you're heading from Yorkville up to Raymond, definitely be careful. Likely we'll encounter some blinding rain, whiteout conditions, winds possibly gusting over 100 miles an hour. Uh-oh, looks like my computer just froze. Uh-oh. Hello? Hello? Damn, does look like my camera's still working at least. Hello? Spectrum Internet, man. Does look like my camera's still working at least. Telling you, this is how it goes. Whole computer just went down. Nice. Gotta be kidding me with this. So, I can still communicate the warnings through audio at least. But yeah, we got these circulations coming in west of Kenosha, Racine, Milwaukee. Looks like the dangerous portion of the storm is moving offshore Milwaukee now, so that warning's going to be allowed to expire soon. West of Kenosha as well, Union Grove, Wheatland, west of Salem Lakes. Looks pretty dangerous out there. The video's still working? Yeah, it is trying to work. Siri, close window. Oh, you gotta be kidding me. Alright guys, still got tornado warnings out there. It's working on your end? Yeah, my whole computer's frozen. I can't, It's possible the video camera's working and maybe the screen isn't working. Could be a total radar meltdown. Yeah, it does look like at least the radar is automatically uploading. Hi there, love, peace, and harmony. Joseph Hardran. Yeah, the screen is stuck, so I can't draw on it or anything. Trying to activate Task Manager. If I reboot that, I'll have to start a new live. And I can't even reboot the damn thing right now. No, it didn't fix it, folks. All right, we'll just continue to look at these warnings. Spectrum caused this. Possible debris signature west of Franksville, Wisconsin. Another one down near Camp Lake is probably more straight line winds. But yeah, that storm right now between Yorkville and Union Grove is really the big dangerous one. Thanks, Cool Roy, for the breakfast burritos. I'm on the gluten-free diet now, actually. Also trying to work on these revisions for our rocket paper. One of the reviewers rejected it. Imagine you can launch a rocket and a parachute probe into a tornado. It gets carried all the way up to 40,000 feet, and they say it's not science. Yeah, I'm usually on the road, Pikachu. Definitely storm chase. I actually don't quite have a... I'm actually at my mom's house right now in upstate South Carolina. I left my vehicle down in Pine Island. The bridges were knocked out by Hurricane Ian. Definitely working through rebirth of Dominator 4. Trying to fix my computer here so that I could resume this tornado live. Yeah, I was able to retrieve the storm surge sensors. Thank you, subscribers, too. But the station is still down on Fort Myers Beach. We weren't able to find that. It was actually attached to the gate on the pier. And the whole pier was destroyed by the storm surge of Hurricane Ian. And I was able to recover the sensor head. But we had to get dropped off by boat and swim in. And then we were able to get that with my good friend Martin Brittingham. He's a former Navy SEAL, actually. And we were able to get down there and get that Surgeonator sensor. Mark has it in his hands right now. So the severe thunderstorm warnings that were in effect in northeastern Arkansas have been allowed to expire. We've just got these 2 tornado warnings in southeastern Wisconsin. The line is moving pretty fast. So there it is. That's the line. It's moving very fast, forcing a more due southeasterly storm motion. Oh, I might have got it to work. Got it to work, folks, I think. There we go, we're back. Boom, we're back. Thank you, everybody, for joining me. I fixed it. Don't even ask me how. There's the skinny squall line advancing. It does seem like, overall, that it is starting to lose its reflectivity a little bit. I wonder if it's starting to run out of real estate, but we still do have this tornado warning south of Milwaukee, Oak Creek, all the way down to the east of Union Grove. This is obviously the most dangerous storm, probably an embedded supercell structure over southeastern Milwaukee. Let's take a look and see if we get any more debris signatures. This one south of Franksville could be a problem. Pretty sure that's a QLCS tornado, or at the very least a damaging straight line event. You can see a little bit of a kink here, little bulge. That could be happening. A better bulge further south. This is the one near Paris, Wisconsin, northeast of Braddock Lake, east of Brighton. I'm not seeing much of a debris signature on that. A lot of these are probably from straight line winds rather than the kinks in the line, but I am definitely seeing down here near Paddock Lake, this zone is definitely a surge of westerly winds. Usually you'll get tornadoes that will develop on the north side of those bulges up near the Paris area, Paris, Wisconsin, north of Paddock Lake. But you can definitely see a well-defined bulge. Big westerlies here. Probably lofting fall colors. Maybe even a little bit more. Maybe some structural damage right there. Boom. Skinny squall line today, everybody, as we're has triggered multiple tornado warnings outside of the marginal risk area too. I do want to take a look at the environment that these are embedded within. There's the slight risk. Let's start off with the RAP analysis. No tornado probabilities up there, which is pretty incredible. Then we'll take a look at a forecast, or at a sounding. A lot of stable air up there, that's for sure. But a lot of times these skinny squall lines move into an environment with minimal instability, but relatively strong kinematics or wind fields. So on this RAP analysis, you want to watch for this area up here, obviously. This portion over southern Lake Michigan likely has low-level stable air. So you definitely want to watch for that little sliver over southeastern Wisconsin and into northeastern Illinois. And let's focus in on that environment. Let's take a look and see what the surface-based instability shows. Nothing. But you can see that there is a bit of a hint of a nose of surface-based instability coming right up into central Illinois. And you can certainly extrapolate that nose all the way up. There's likely a little belt of surface-based instability right in this zone that reaches all the way up to that skinny squall line, giving just enough moisture to cause a relatively shallow, stable layer at the surface. But you can definitely see the hint at a nose of instability streaming up, and I bet we're talking big-time wind shear. We're not. But that's also because this effective storm relative helicity likely factors in a storm motion if an individual supercell storm were to develop in this environment. Then you'd have a more southwest and northeast storm motion. But these squall lines, these skinny squall lines, are surging west-northwest to east-southeast. And that's not the storm motion that the model is factoring in when it looks at storm relative wind shear. Let's look at bulk shear in the lowest kilometer. And there's your wind shear. We're able to pick it out. You do have about 30 knots of bulk shear in the lowest 0 to 1 kilometer. You can see this area right here, right ahead of the front over southeastern Wisconsin and in northeastern Illinois. Basically, if you have enough bulk shear greater than about 20 knots in the lowest kilometer or so, if you have one of these skinny squall lines just surging into that area, forcing a storm motion that's a little bit more right, you're going to be able to squeeze a lot more out of that environment. So the storm relative helicity, showing it relatively non-existent. You look at the bulk shear in the lowest kilometer, and it definitely pops out. Plenty of bulk shear out there with 60 knots. Definitely a well-defined trough nosing in. See if we can find a morning sounding. Don't have any. Let's look one down near Davenport. There's your sounding. Let me push that up a little. It does show a little bit of a capping inversion, but some decent moisture near 60 dew points, 57 dew point. The lapse rates aren't great, but you do have some decent moisture at the low levels. The green is the dew point line, and you can definitely see it's relatively close to the red line over a relatively deep layer. You do have some pretty good moisture, and the low level lapse rates aren't terrible, and that's at 12Z. That's the morning sounding down near Davenport. Let's take a look at the surface map. And then we'll also look at a hodograph. There's their dew points, upper 50s all the way up, strong southerly flow. Temperatures into the middle 60s. definitely not impossible to get a tornado in that environment. But basically, the bottom number, the green number, is dew point. You can see your dew points are up into the upper 50s. We got 57, even some 58s. Temperatures rising up into the middle 60s. One great website to look at real-time soundings is this autumnsky.us sounding, and you can actually plot them using VAD profilers. We could look at Milwaukee, but that's just behind the gust front, so we're going to pick one down in Chicago and see how that wind shear is looking. There's your hodograph. You can definitely see the bulk shear. So that's basically your wind field. This is the origin, obviously. Your surface wind south-southwest at about 15 knots. Your 1 kilometer wind, you have some directional shear west-southwest at 40 knots. So there's your 0 to 1 kilometer bulk shear that's being analyzed by the RAP analysis. It's in excess of about 30 knots. The tip of those vectors, that's your bulk wind shear. But if you have a storm motion that's right along this straight line, it's a straight line hodograph. And if you were to have a supercell just embedded in the open warm sector, it would probably move off to the northeast. Ahead of that potent trough, a lot of southerly winds. But what the skinny squall line does is it forces a storm motion almost due east, even east-southeast. So it forces a further east-southeast storm motion, and it's rapid too. Probably well in excess of 30 knots, maybe even out near 40 knots, that storm motion. So your storm motion dot is down here, and that's a near 90-degree angle with that 0 to 1 kilometer shear vector. Especially the 0 to 500 meter shear vector, it's closer to 90 degrees. And when that critical angle with your 0 to 500 vector with the tip of the storm motion is close to 90 degrees, then you're likely pulling in some more streamwise vorticity at the low levels. And if you have a storm motion that's accelerated by that skinny squall line, your storm relative inflow is maximized and you are just cranking, just pulling in that streamwise vorticity, eating it like the Cookie Monster. And that's why we've had this tornado outbreak over southeastern Wisconsin today. Let's look at one a little further south down near Memphis. And then we're going to go back to the radar. And the hodograph isn't quite as favorable down in Memphis. You're lacking the bulk shear. Your surface wind southwest to northeast at about 15. 1 kilometer wind. Still a little bit of directional shear, but not as strong. West-southwesterly at 25 knots instead of 40. So your bulk shear in the 0 to 1 kilometer layer, probably about 15 knots. And definitely not enough to generate a QLCS tornado event further south in the slight risk area. We've also got this convective complex out in Alabama that's likely destroying the instability over the open warm sector. Let's go look again at radar, see if we have any active tornado warnings that we need to watch out for. We obviously do over southeastern Wisconsin. It includes the Kenosha area. And we still have this dangerous storm coming into Summers. Little kink in the line south of Summers. If there was a tornado, it'd be happening in this zone. Here's Summers in Wisconsin. Here's Kenosha, included in the tornado warning. You got an RFD bulge just to the south of it. Basically a accelerated westerly winds behind that gust front. And usually on the north side of those accelerated westerlies is where you're going to get the generation of tornadoes. Just on the north side of that bulge, up in this zone, is where you want to watch for tornado formation. Let's take a look at the correlation coefficient. We can see exactly if there is one. Looks like you're getting some fall colors getting lofted out here by the accelerated westerlies behind that bulge, but I'm not seeing a definitive tornado signature right now. Yeah, within this zone of westerlies, I think that you're probably lofting a lot of leaves as well. Very strong westerlies within that bulge. I'm not ruling out the chance of there being a QLCS tornado embedded behind this gust front, a little bit smaller than the resolution of this radar is able to depict. And these are very low top too. You can look at echo tops on here and just watch how low top this convection is. So these skinny squall lines are very low top storms. We're talking about 15,000 foot tops. But a lot of times when you compress a storm in the vertical, the mesocyclones will spin a little bit faster, and that's also at play here with these QLCS events. You're almost compressing the storm systems from the top. Any areas of rotation will accelerate a little bit more. I was reading some studies about how gravity waves can come in and compress the top of a supercell storm and actually cause the mesocyclone to rotate faster. You would think that if you're compressing it, it would rotate slower, but it seems a bit counterintuitive when I read the paper, to be honest. I just think the word gravity wave sounds cool, so it's pretty easy to get any paper on gravity waves. It's probably easier to get out the door sometimes. But look at that gust front advance rapidly. Rapid advancement of the gust front into southeastern Wisconsin. Kenosha, you're next in line, possibly some damaging winds. I do think that the tornado threat is decreasing because it looks like this gust front is surging a little bit too fast, likely sliding in over top of that increasing stable air over southeastern Wisconsin, causing it to slide over that relatively frictionless surface. And it seems like it's a lot less effective at pulling an inflow. We got one more chance down here to the west of Kenosha, though. This one out here might be a little kink that can stretch into the vertical and become a tornado. Racine, the gust front has just moved out over the open waters of Lake Michigan. This is Lake Michigan out there, so good news in Racine. That squall line moving offshore. Probably see some departing water spouts moving at like 50 knots out over that beautiful Lake Michigan waters off of Racine. Kenosha, you're next in line. Squall line headed your way, but I'm not seeing as much in the way of tornado potential anymore with this line as it's starting to approach Lake Michigan. We do have the skinny squall line that's approaching Kenosha area. Looks like we still do have this embedded supercell structure to the west of Kenosha. We're seeing the gust front is now offshore. So I think that this section of the tornado warning soon is going to be canceled, and you're just going to be left with a sliver of a tornado warning that includes Kenosha or southeastern Wisconsin. Further south, down in the Illinois side, severe thunderstorm warning now includes North Chicago. Looks like we've got this wispy, weird little supercell structure still left over to the west of Lindenhurst. And there's even a kink in the line with that supercell structure. There is an outside chance that we could still get a tornado warning out of this. To the west of Venetian Village, west of Lindenhurst, Lake Villa, west of Grandwood Park. And you can kind of see how these gust fronts have a kink. The gust front here more southwest to northeast oriented. And you have a bit of a bulge on the south side of that elevated mesocyclone. But right near the kink is where you want to watch for tornado formation. The kink of those two gust fronts. That's the zone you want to watch, north of Round Lake Beach. I'm not seeing very much in the way of velocities that would trigger a tornado warning yet. You can see this little transient supercell storm, very low topped, only about 15,000 foot tops. But the wind shear is so strong that it still is able to attain a supercell structure. Look at that, even a little bit greater velocities now west of Venetian Village. Wow. Let's see if the latest scan tightens up that circulation at all. Anytime you have these kinks, there is the outside potential of that the storm could become tornadic. Just got to keep an eye on it. Zooming out a little bit, the kinks are becoming less well-defined on approach to Kenosha. So I think that the tornado threat just not as likely there. Look at that gust front. Look at that blob too. That little transient supercell storm is about to move out over open Lake Michigan north of Kenosha. Still has a little bit of rotation, but not not that much. I mean, you probably just have a hint of some northeasterlies that are being picked up by the radar within this. Just on the north side of this little RFD bulge. You do have some westerly winds that are still ripping right there. I wouldn't say ripping, but it does seem like the velocities are coming down anywhere within this line. So I suspect that these tornado warnings are going to be allowed to expire shortly, but it is coming into Kenosha. And it probably is about to move offshore shortly. Again, the slight risk area. There it is, folks. All these tornado warnings just outside of the slight and the marginal risk, but it is very difficult to forecast these low instability, high wind shear cases with a skinny squall line that's moving through southeastern Wisconsin. Slight risk does have some greater instability, and that includes the Nashville area. I do want to look at some of the forecast models for that zone next. Tornado probabilities continue. That's going to be more of a traditional afternoon event. At the same time, though, a lot of limiting factors for this to happen. There's a ton of cloud cover. There's even this convective rain blob that's happening right now over central Alabama that's associated with more cloud cover. You've also got this surging front with less low-level wind shear. So I think what you're going to get is scattered severe storms along the front. Probably less likely to get those prefrontal confluence bands of storms that'll be able to tap into a little bit better but still marginal low-level wind shear. Maybe up here into southern Ohio, northern Kentucky, though, could have the outside chance of a tornado or two. I am now going to take a look at some of the forecast models for the slight risk area as we go through the afternoon. Let's take a look at some of the latest updates. I do plan on bringing my car back too, so don't worry about that. It might not be in its exact previous form, but I think I'm going to be getting a 2018 Forester and then taking the exterior off, taking the doors off of that car, taking the hood off, and then just remounting them on the new frame. That's my goal right now. This is at 19Z. This is 2 p.m. Central Time. We're looking at 850 millibars, 850 analysis here, or forecast for 19Z. And kind of a weaker low-level jet out ahead of the front. But definitely some stronger low-level flow being evident in the northern edge of that warm sector. That would be southern Ohio into northern Kentucky. A reduction, though, in the low-level shear as you get further south across eastern Arkansas, western Tennessee. This is all kind of post-frontal, where you get that accelerated low-level jet. Seems to be just behind that front. The wind shift is a little bit further back across southeastern Missouri. See holes. Even the moisture isn't very great down here across the mid-south. But you have had a little bit more surface heating. And so there's your cape as of 19Z. That's your surface-based instability. You can see the hole in the cape here that's caused by that blob of convection or blob of storms over central Alabama. But you can see the instability building a little bit back behind it. This is a forecast for 2 p.m. The nose of the surface-based instability tries to poke up into western Tennessee. Sometimes a better way to look at the combination of instability and low-level wind shear is through energy helicity index. This appears to be mostly post-frontal across eastern Arkansas. See these westerly winds, mostly westerly winds. You do have some 84 over 64 low-level temperature profile. You do have these steep low-level lapse rates, but look at that. Westerly winds all the way up and down the profile through eastern Arkansas. That's only going to generate severe storms, no tornadoes. You do have some decent instability up here. Decent lapse rates all the way up into the mid-levels. They're in excess of 2,000 joules per kilogram surface-based cape as well. So you do have some decent cape across eastern Arkansas, but the wind shear is very reduced. You need to go to the east of one of these prefrontal confluence lines or little cold pool lines to find some better wind shear. And it does look like over northeastern Mississippi, You have slightly better wind shear, low-level wind shear, coupled with surface-based instability. The photographs are looking a little bit flat, though. You just don't have that low-level jet that's gusting 30, 40 knots, even greater than that. If this photograph extended a little bit higher up, more like that, then we'd be talking strong tornado potential. I'd likely have to take my mom's car, get out there and storm chase. But because that photograph is a lot flatter, you have a weaker low-level jet. We saw that on the forecast models. It's going to lead to a more marginal tornado threat. But it is non-zero. There is a tornado threat there. You do have these southeasterly winds in the lowest kilometer, flipping around to west-southwesterly. You do have some directional shear across northeastern Mississippi. And look at that dry slot coming in here as well. That should clear out a little bit of cloud cover and might lead to some more surface heating. Meridian up to Tupelo, near 2,000 Cape, near 0 to 1 kilometer storm relative felicity, just greater than 100. And that's because of these flat photographs. Talk about 5 to 10 knot shear vectors in the lowest kilometer. But the nose of that favorable environment does stick up to near Nashville this evening. And it does look like you may have a low-level jet that's pushing 30 knots. But if you had that low-level jet up near 40 knots and you had these larger looping photographs, then I would think that there's a better chance of a tornado. But if you can get a little supercell storm that develops out ahead of the front, this photograph is supportive of a low-end tornado threat, especially with that storm motion due east at 30 knots. You do have quite a bit of storm relative inflow at the low levels. Steep lapse rates at the nose of that instability, so there are some breaks in the clouds that the HRRR is indicating. Decent moisture as well with those dew points moving up into the low to mid 60s. Hey, JR. Sorry, Cajun Navy friend. I'll call you right back, JR. $5 p.m. Here's 6 p.m. Definitely get better instability across eastern Arkansas. And the main environment, the most favorable environment based on instability and low-level wind shear is probably northeastern Tennessee, or northeastern Mississippi, Meridian up toward Tupelo. You do have a hint of some surface-based instability up into southwestern Ohio, though. Let's look at some forecast soundings up into southwestern Ohio. Better photographs, but a lot more stable air at the low levels. Look at that. You don't have those steep lapse rates at the low levels. A lot of stable air up into southern Ohio. But you do have slightly better photographs. Your low-level jet is pushing 30 knots. Not too dissimilar from the forecast photograph, though, that we were looking at on the nose of the instability up into central Tennessee. But that does look supportive of a tornado or two. If you can get some smaller scale supercells, probably lower top supercells up across southern Ohio, definitely could be a couple of tornado warnings up there. These storms behind the line are going to be more hail producers, straight line wind producers with all those westerly winds throughout the profile. And then you get more of a convective line. Maybe you'll get some more QLCS circulations moving into central Tennessee, possibly impacting the Nashville area, 6 or 7 p.m. Keep an eye on this line for tornado threats embedded within the line. And these models are even showing the threat of a couple of bean-shaped supercells up there by 6 or 7 p.m. near the Ohio River, southwestern Ohio. It's very possible that we could get a tornado or two up there. A low-level jet does accelerate up to 40 knots, but look at that stable air at the low levels. These are likely going to be elevated supercells. That's a pretty big inversion there at the low levels. It's going to be difficult for that to overcome. And because of that inversion, you do accelerate the low-level jet over top of that, pushing 40 knots. South-southwest and north-northeast at 40 knots. Pretty good bulk shear vectors from your surface wind, or your 0 to 1 kilometer shear, bulk shear vectors of about 40 knots. But different than southeastern Wisconsin, your stable air is a little bit more robust at the low level, so I think it's going to be difficult to even get a QLCS event up there. Unless that front is able to force a further right storm motion, due east or even an east-southeasterly storm motion, then you might be able to strengthen the low-level mesocyclone enough to even drill through a capping inversion that is that robust, but chances are pretty unlikely of that happening. Overall, though, your southwest low-level jet is stronger up across northern Kentucky into southern Ohio. Should be a little bit more favorable up there for a tornado potential. Looking at this zone right here. But the instability is just not there. That capping and that inversion at the low levels is just too robust. But you can see your 0 to 3 EHIs right along the Ohio River. Look at that. Inversion at the low levels. Very well-shaped photograph up there near the Ohio River, though. So if you get any surface-based storm, and if that inversion is not as robust as the models are indicating, it's possible that you could squeeze out a tornado or two, even across northern Kentucky into southwestern Ohio. Still have this severe thunderstorm warning over northeastern Illinois. I'm going to show you that. It includes Waukesha. And even though the tornado warning is still in effect over southeastern Wisconsin, that's also going to be allowed to expire soon, because the gust front has now moved out over Lake Michigan. Here's your convective line. This is the Lake Michigan shoreline. So this tornado warning is going to be allowed to expire very shortly. Still watching this area upstream of Waukesha. Only a yellow box is in effect now, but you never know with these QLCS circulations. You might be able to squeeze out a little tornado or two. But I suspect that this stable layer at the low levels is probably a little bit too robust at this point. Skinny squall line about to move out over the open waters of Lake Michigan. So thank you, everybody, for tuning in to this weather report, an emergency weather report, as multiple tornado warnings happened along that skinny squall line in southeastern Wisconsin. I'm going to get back to the rocket paper revisions and grinding through some of these revisions. 3 of the reviewers, incredible revisions, significant revisions, but definitely needed, certainly improved the paper. One of the reviewers appeared to be a bit biased, though. Probably a hater of sorts. But publishing the rocket paper, 2023 Spring Team Dominator is planning to launch dozens of sensors into tornadoes. Right now we just have the one trajectory up through the supercell storm. But it shows that above the tornado, hardly any rotation, at least near the center of the mesocyclone. I believe that you have a pipe, almost like a smokestack, that goes all the way up from the tornado, up through the mesocyclone, all the way up to the triple pause, highly tilted, especially during the strong wind shear cases. I think that's why you a lot of times still see that bounded weak echo region on radar, even when the storm's relatively far away from the radar. I think you choke that pipe off, the lower level of that pipe, you choke it off from the heat and moisture at the low levels, and suddenly you get an elevated hail producer, predominantly a hail producer. And boom, that tornado warning has been allowed to expire. Still left a severe thunderstorm warning up there from Kenosha down to Pleasant Prairie. Likely in case there's a rear inflow jet or a wake low of some kind. Sometimes on the back side of these rapidly ejecting squall lines, you can get some strong westerly winds that'll even be well behind the convection. So, see how many tornadoes have been reported, preliminary reports that are included in the SBC archive. Probably 0 if I had to guess. Oh no, a bunch of reports. Holy cow. 6 reports. So we do have a tornado outbreak, regional tornado outbreak of storms. But look at that little cluster of red dots up there. 6 tornado reports. Whitewater County, or excuse me, Walworth County near the town of Whitewater. Observe rotation, condensation funnel in contact with the ground just south of Highway 12 and Highway 59. And then some of these other reports, Elkhorn. These are all visual reports too. Racine County, Waukesha County, Milwaukee County, Brown Deer, and we were actually watching a lot of these in real time with those debris signatures as they were happening. Wow. Had a large hail report in western Alabama down there. 2-inch hail in Hale County. social media photo of large hail near Galleon, 12:30 this morning. So that was at 7:30 in the morning. And that's also consistent with our rocket paper. That early in the morning, you usually have a stable layer at the low levels, a shallow stable layer. And I think that you likely choke off that smokestack inside the supercell storm at the bottom of it. Supercell becomes a little bit elevated. And then instead of just having that heat pipe pumping heat and moisture up through the center of the supercell storm, all not dissimilar from the eye of a hurricane storm, which is in a more barotropic environment, more vertically oriented heat engine. Supercell storms feel the baroclinicity, they feel the jet stream, they're more tilted, smaller scale features, smaller mesoscale. But on the outer sheath of that smokestack, you got a cyclonically rotating mass. Basically a sheath that's spinning, and all the time lapsers, when we're looking at supercell storms from a standoff range from long distance and you see that mothership spinning in a circle, that is actually the outside of the smokestack, outside of the part that's really responsible for the tornado genesis, that's responsible for the heat transfer of those supercell storms from the near the surface up to a loft in the troposphere. Carl still now is forecast to move back toward Mexico, wobble back toward Mexico as a tropical storm. Hello? Hey, I'm live right now. Okay, I'll call you right back after this live. All right, thanks. That was Brian. Good Brian O'Toole. He's helping me improve the production quality on our social media at Team Dominator here. Let's take a look at some of the new hurricane models with Carl. Here's Satellite on Tropical Tidbits. Definitely a convective burst happening, and it does look like that convective burst is relatively close to the center of Carl. See if we can see any low-level circulation that's migrating out. There's the low-level circulation. Looks like the low-level circulation is out near the northwestern portion of that convective blob. These whiter clouds are the higher cloud tops, but boy, it does look like a pretty well-organized tropical storm. And it's obviously battling a little bit of dry air that it's pulling in from the north off the western Gulf of Mexico. It's got a little bit of a tilt, but it does look like this is forecast to drift off to the south and likely will cause some flooding concerns over southern Mexico. These are the hurricane models. Definitely a consensus taking it off to the south. A little bit of a shift further east compared to the official forecast. It's a bit of a wobbler out here. And this is actually the northern portion of Julia that broke off, and that convective blob just sat over the Bay of Campeche here. Very warm waters, and just gradually intensified and organized into a tropical cyclone. But a majority of these forecast models now drifted back south over southern Mexico. Big rain, flash flood potential, mudslide potential over southern Mexico with Carl. Ignoring the Gotti model there, taking it to the north. .40 knots. Not much intensification out there either as it drifts off to the south. So Carl is probably only going to be an issue for southern Mexico there, but certainly could be some potential. Look at the windy.com app down here at this thing. Ooh, look at that closed circulation. Great app that now has this hurricane tracker feature on it. But the faster winds here, right on the eastern semicircle of this tropical cyclone. But of course, it does have that closed rotation. It's a tropical storm. And I can show you the hurricane tracker feature. We got waves too out here in the Bay of Campeche. Waves up in excess of 20 feet on the eastern side. There's the official track. Definitely showing a drift off to the south and even a weakening tropical cyclone, but still producing a bunch of rain. There's the European model forecast still holding out a little bit further west, where the hurricane models are now taking a direction a little bit further east. And there's the majority of the convection, just a little bit separated from the center. The majority of the convection just off to the southeast. I wouldn't be surprised if that center tries to propagate southward where the greatest latent heat release is happening. And that's probably why this thing is going to meander off to the south and definitely be more of a rainmaker down into southern Mexico. This is all where your thunderstorm activity and lightning are located. Low-level center a little bit on the northwest periphery of that convective blob. A lot of times these tropical cyclones earlier in their life cycle, the low-level center will be a little bit displaced from the mid-level and the convective blobs that'll happen. There's your blob of convection. Weakening a little bit, as often happens during the day hours after a convective burst. That'll happen in the overnight hours. A lot of times these storm systems will kind of ebb and flow. They'll blow up in the middle of the night, come back down a little bit during the middle of the day. So thank you everybody for joining this weather report. It was more about those tornado warnings, multiple tornado warnings happening over southeastern Wisconsin. Thank you everybody. Hit that subscribe button, notification bell if you want to. Never